Okay, today's notes I'm going to show you guys how to simplify radical expressions when you have odd exponents inside the radical. Okay, so let's remember from Friday or today that the square root of a squared is the square root of a times the square root of a. Okay, and therefore that equals a. Okay, so now if we have the square root of a cubed, okay, we could break that down to the square root of a times the square root of a times the square root of a. And if we go back to this, we see that the expression, the square root of a times the square root of a, that is a, and we're left with a times the square root of a. So this is equal to a times the square root of a. Okay, so let's break down a couple other ones. We've got the square root of a to the fifth. We could say that that is the same as the square root of a to the fourth times the square root of a. And we remember from doing simplifying radicals with even exponents, the square root of a to the fourth is a squared. So that's a perfect square. That's a squared. I'm left with a on the inside, so the square root of a. Okay, x to the ninth, can break that down to be x to the eighth times the square root of x. And so then that's x to the fourth square root x. Okay, and if you want to try the square root of y to the 17th, you can do that on your own. Okay, so here's an algebraic rule. If x is an odd number, okay, I think when we did it in class we had a to the n, but if x is an odd number, you can just say a, and then it's raised to the power x minus 1, divide that by 2, and you're always going to have the square root of a still in there. So if x is an even number, it's a perfect square. If x is an odd number, you do not have a perfect square. You're still left with something inside the radical. Okay, so let's simplify these. Okay, so the square root of a to the 7th times b to the 11th. I'm going to break that down to a to the 6th times the square root of a. Okay, I'm finding the factors that are perfect squares. And then b to the 10th. And then b. Okay, so now find the perfect squares. Well, a to the 6th, the square root of a to the 6th is a cubed. And the square root of b to the 10th is b to the 5th. And inside the radical, I'm left with ab. And since the square root of a times the square root of b, we can write as the square root of ab. And we remember that from a couple days ago. Okay, let's do this next one. Okay, I can break that down to the square root of x to the 4th times the square root of x, and then the square root of y squared times y times the square root of z. Okay, and so my perfect squares here are the square root of x to the 4th, which is x squared, square root of y squared, which is y, and what am I left with inside the radical? I'm left with x, y, z. Okay, if you want to try this one on your own, you can. All right, let's try, we're going to actually try the second two because I think those are the ones that would be tougher. And I've got a minute left, so maybe we might only get through one. So the square root of 16, x to the 9th, y to the 6th, z squared. Okay, well, the square root of 16, I know that's a perfect square. And the square root of x to the 8th, that's a perfect square. I'm left with that times the square root of x. The square root of y to the 6th, that's a perfect square. And the square root of z squared. Okay, so now let's pull out all the perfect squares. Square root of 16 is 4. Square root of x to the 8th is x to the 4th. Okay, the square root of y to the 6th is y cubed. The square root of z squared is z. And inside the radical, I'm left with whatever was not able to be square rooted, and that's x. Okay, and so that's the simplified, that's that simplified. All right, we are out of time. Why don't you try either the two on here, you guys can try the ones on the worksheet, and the answers are online for that. Okay, see you Tuesday.